What would occur if the Earth's rotation stopped? It's feasible that the Earth will come to a complete stop in billions of years. However, there's a significant probability that something else will happen first, like the planet being swallowed up by the sun. Considering that, it is unlikely that the planet will suddenly stop spinning anytime soon. However, supposing for the time being that the Earth did abruptly stop rotating and examine what might transpire to us and the Earth. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. What if the Earth stopped rotating? Briefly rotating, it would be nice. Become disastrous terrible because we are currently experiencing on the basis of our latitude. You can determine with the Earth, we are all in motion. Due to speed of 800 miles per hour east because the planet is rotating, if you stopped planetary surface and your seatbelt wasn't fastened, if you were to fall to the ground, you would turn directly east at 800 miles per hour. Every human being on the planet would perish. That would result in birds flying out of windows, merely be an awful day on Earth. At its equator, our globe rotates. As it revolves around the sun, it rotates at 1,000 miles per hour, but as you approach nearer the poles, it slows down. Life as we know it would not be possible without this rotation. It is believed that our globe used to rotate far more quickly than it does today billions of years ago. When a mysterious planet or other massive celestial objects first impacted with the Earth in our newborn solar system, the Earth's atmosphere was destroyed. The Moon was created and the alignment and spin were altered. The Earth's rotation has slowed down since that time. Before it became tidally locked with the Earth, it is thought that the Moon also used to spin more quickly than it does now. When a moon or other planetary object's orbital period coincides with its rotational period, the phenomenon is known as tidal locking. Interestingly, every single giant moon orbiting a planet experiences the same fate, with our own moon serving as a prime illustration. The Earth and Moon rotated independently of one another in the early solar system. But the tidal bulges were seized by the Earth's gravity, which delayed the Moon's spin. The Moon moved away from the Earth to its current distance of approximately to make up for the system's loss of momentum. 300.000 miles distant, but the Moon also affects the Earth, and the same tidal forces that created the Earth's tides are gradually slowing the Earth's spin while the Moon continues to stray a few centimeters every year to make up for it. If the planet were to suddenly stop spinning, there are two possible outcomes. However, if the planet weren't tidally bound to the sun, there would be 6 months of daylight and 6 months of darkness. But let's examine the outcomes for the sake of this thought experiment. It would have been tidally locked to our star, the sun, on our planet. We must first take into account how quickly our planet revolves at its equator, which is almost 1,000 miles per hour. Everything on the surface of the globe would abruptly accelerate to a speed of more than 1,000 miles per hour if there were a brief pause. 1,600 kilometers per hour in a counterclockwise motion, everything would remain affixed to the Earth's surface because the velocity required to escape the gravity of the planet is greater than 24,800 miles per hour. But jolted ahead, imagine the world all of a sudden moving at 1,000 miles per hour. What it was wouldn't matter. 3/4 of Earth's gravity would decelerate everything sideways, and then suddenly everything would be falling at an angle of 38 degrees from vertical. Buildings would be toppled from their foundations by the power of a sudden stop, and any other object that isn't solid bedrock should be used to launch them across the ground. A massive and catastrophic debris path, devastating everything in its path. The oceans would also be affected by this, since they would abruptly spill sideways over the world. But that's not all. With waves traveling at the same speed and being thousands of kilometers high, think of a tsunami that was so high that you couldn't see the top. It's just a wall of water coming at you at 1,000 miles per hour. The end of much of life as we know it would result from any of these two catastrophes. The atmosphere would continue to spin at the same speed as the Earth, even though the Earth would stop spinning. It would produce extremely strong winds and violent storms. Due to the Earth's rotation, the planet bulges along its equator due to centrifugal force. Lacking rotation, you don't have a bulge. The additional water that has been held in place near the equator would surge back toward the poles without that bulge. When the world stops spinning, you must remember that the inner core of the planet is spinning more quickly. The Earth's core hasn't necessarily slowed down just because the surface has. As the tectonic forces above and below engage in a new struggle, our highly volcanic planet may erupt in ways we never anticipated. Supervolcanoes would probably erupt all over the world. Half of our tidally locked world would always face the sun, while the other half would always be in complete darkness. Our planet is currently in a region known as the Goldilocks zone, or zone of habitability, where life can exist at the ideal distance from our sun. There may still be regions of the world where the climate is livable. However, if anything survived the past disasters, it might be difficult for life to live on the two extreme extremes. There was still any discernible amount of life on the planet's surface. It would now have to remain alive in the area between the two parts that would experience nightfall. We are sufficiently removed from our star for the surface of the Earth to that would be exposed to the sun wouldn't burn or burn up overnight. However, the planet's hot side's atmosphere would begin to destroy the surface. A section of the planet that is always in the sun would get more sunlight. More heat would result from these high temperatures, with the resulting heavy rain and increased weathering. The Earth's climate is regulated by regular weathering. However, with one side of the Earth being hotter and the other being colder while still being on the hot side, as atmospheric gases accumulated, more heat would be produced. The runaway greenhouse effect is what is causing this. Gaseous clouds might drastically raise the temperature, similar to what happened to Venus, to the point where the oceans would boil. The substellar point, or the center of the planet facing the sun, would become extremely hot. That very little could survive. On the other hand, the scenario would be different on the cold side of the planet. The atmosphere would become a thick gas as a result of the sun's heat being lost on the Earth's dark side. The liquid will then continue to condense until it becomes solid ice. Of course, it seems unlikely that the atmosphere on the planet's dark side would solidify. Instead, it would continue to condense, leaving a vacuum, which would draw air from the planet's heated side, where the atmosphere's gases would be expanding. If this were to occur, it's feasible that the planet's atmosphere would become habitable. However, the storms brought on by this mixing of hot and cold air would be unthinkable. Superstorms would occur on both sides of the planet. He scrawled it in the sand while the wind was powerful enough to shred the very rock. The next likely event is that the Earth's magnetic field would stop renewing and begin to gradually erode over time. This is due to the fact that the Earth's magnetic field is a dynamo action using its rotation that produces power. Our magnetic field is essential for maintaining the integrity of our atmosphere and shields the Earth from cosmic rays. What would become of humanity? Being very adaptable, mankind have appeared to withstand other calamities, and although we have strong, it would be extremely difficult for technology to exist on a planet that has ceased spinning and is tidally bound to the sun. By going underground, we could somewhat regulate our environment. But it might be tough to grow food under such circumstances. However, as physicists, you shouldn't be concerned about this happening anytime soon. Anticipated that at the current rate, it would take 1 billion years. Comment below and tell us what you would do and how you would handle these new obstacles. Thank you for watching and see you on next video.